Hello everyone. We have discussed manometers in length in the last session. Now we'll solve some numerical problems on manometers so that your idea of manometers is consolidated. So this is basics of manometer. We'll revise quickly. Already you know this, that a piezometer which is attached to a point over here A, right, and then it has got a open piezometer. The level difference between free surface of the liquid to a point A is indicated by H, and then if the liquid has got specific weight gamma, the pressure at A, PA, is given by gamma H, and this pressure is gauge pressure. So PA is given by, now how do we write this? PA, that is pressure at A, will come from the free surface. Starting point to write the equation is free surface, where the pressure is atmospheric pressure, which is taken as 0. Please concentrate what I am trying to tell you. We start with the free surface wherein the atmospheric pressure is acting. That will be considered as 0 because we are trying to evaluate gauge pressure. So atmospheric pressure is taken as 0, and then when we move down into the liquid, we add, there is a plus sign, and we are going in the liquid of density gamma, not density, specific weight gamma, or gamma 1 I have written. Through what distance? Through a distance, say h1. So gamma 1 h1. Then this gives you pressure at this particular level or anywhere along this line. Horizontally, when we move any point over here, whether you put it as A, B, C, any point along this horizontal level, it will be equal to gamma 1 h1. We have seen this. Anyway, you consolidate the idea. Next, relative density is nothing but specific gravity in fluid mechanics, represented by capital S or SG, specific gravity, right? So we should be knowing that specific weight gamma is equal to S into gamma W, because specific gravity we have defined as the ratio of gamma by gamma W. Using the same in this manner, gamma specific weight can be written as specific gravity multiplied by gamma of water, and specific weight of water, gamma of water, is equal to 9.81 kilonewton per meter cube, or it can be put as 9810 Newton per meter cube, specific weight of water. Now this is a U-tube manometer. This was simple piezometer. Here it is U-tube manometer. You can just see here there is a shape of U, and invariably there will be a different liquid which is known as a manometric liquid, shown as brown color over here, having unit weight or specific weight as gamma 2, and then the liquid in this container is having gamma 1, right there. Now here, how to analyze U-tube manometer is look at this level BC. At B and at C there is same liquid, brown liquid. So when we move horizontally, if we are in the same liquid medium, the pressure remains the same. That is a concept we are going to use. So pressure at B and pressure at C are equal. That is the crux, that is the important point that we are going to analyze more and more. So here there are some points already we have discussed about this. Now we'll see how to write pressure at B. Pressure at B can be written as, pressure at B can be written as, if we start with pressure at point A, right, horizontally if I move, even at this point it is pressure at A, then when I move down I have to add. So pressure at A plus, in what liquid? In gamma 1 liquid. Through what distance? H1 vertical distance. So pressure at A plus gamma 1 H1, I'll reach the point B. So that is what is PB. PB is nothing but PA plus gamma 1 H1. It should be equal to PC. Now how do I write expression for PC? Again, I'll start with a free surface where the atmospheric pressure is acting, which is considered as 0 because we are working out with the gauge pressures, 0. When I move down, right, I'll have to add, that's why there is a plus sign. We are moving inside the liquid of gamma 2 through a distance of H2, that's why it is gamma 2 H2, which makes the pressure at C. And now these two are equal. Now I can write expression for PA as minus gamma 1 H1 plus gamma 2 H2. This is how to analyze manometers. Okay, now we'll see actual problems. Slightly involved problems I have taken, so try to understand them so that you can solve the other problems quite in an easy manner. Okay, here there is a problem. A tank in figure, there is a tank in figure, is closed at the top, it is closed at the top and contains air at a pressure of PA. There is a air here, and then gauge reading over here, it is PA for the manometer readings shown in figure. Contains air at a pressure PA. Now calculate the value of PA for the manometer readings shown in figure. Now you have to find out the value of PA using all this information. Now what is done here is, there is a oil standing with a relative density here, specific gravity 0.75 for a height of 150 centimeter or 1.5 meters, and then there is a water here. The water is going through a U tube, and then this tube is open to atmosphere, and there is a mercury here which is in this manner, and the difference in mercury level is given to be 10 centimeter, and then the level with this level over here is shown as XX. Okay, now how to solve the problem? Anyway, the idea is over here to identify, make a note, we have to identify horizontal level of the same liquid. Now do we have water and then the same level over here? No. Relative density, oil is above this, so there is no question. So the only way how we can search for is, in mercury at this level of XX, this pressure at X and this pressure at X is same. Now if we are able to write those expressions for pressure on this side, left hand side of the limb and right hand side of the limb, then we have solved the problem. Okay, we'll see how we can do. Now first of all, how to make use of specific gravity. Gamma with a suffix O, the specific weight of oil, is equal to specific gravity multiplied by gamma W. Specific gravity is given to be 0.75 into 9810, gives you 7357.5. Units will be Newton per meter cube, because this hasn't got any units. Specific gravity, gamma W has got units of Newton per meter cube, the same will be maintained. Now mercury, gamma M, specific weight of mercury, is equal to specific gravity multiplied by gamma W, 13.6 into 9810, gives you 133,416 Newton per meter cube. Now here, considering the pressure at the horizontal plane XX, P, the pressure at X on the right hand side of the U-tube is equal to P at the same level X on the left hand side of the U-tube. Now how do I write on the RHS, right hand side? Now if I go up and then search here, I should start with PA. The pressure at this point, or pressure inside the air at this gauge, is PA. Now we'll start with PA. You can just see here PA, and when I move down in air has got hardly any value of gamma. Because of that, there is no contribution of gamma H as far as air is concerned. Make a note of this. In air, when we move down or up, hardly there will be any contribution. But if you move in the liquid, obviously the unit weight of or specific weight of liquid contributes for the pressure. Now PA, which is at this level, will be same as everywhere here, PA at this level. Now this PA plus, because when we go down we have to add, so this is plus. Through what distance? Through 1.5 meters. In what liquid? In liquid of oil. So that is specific weight of oil. Specific weight of oil multiplied by 1.5. Now in water, I have to go right up to this particular point, means from here to here. Now how much is that distance from here to here? We can just see here, if I have to analyze, here there is a level. Up to this level it is 1.5, and then from here to here it is 2 meters. So this distance is 0.5, which is 2 minus 1.5, and then there is plus 0.1, right? So step by step I'll come from here to this level, which is 2 minus 1.5 multiplied by gamma W. I am going down, that's why I have added up. I have come up to this level now. Now still further down I have to go in water only through a distance of 10 centimeter, which is 0.1 meter into gamma W. Then I'll reach at this level. That's how I have written. On the right hand side, Px is given by all this expression, and it is equal to, on the left hand side at this level. Now how do I write this for this? I'll start again at free surface, which is 0, and I go down. That's why there is a plus sign. No sign in the sense plus sign. Through what distance? Through 0.1 meter in mercury. So 0.1 into gamma m. If we have written this equation, you would have got more than 50% of the marks. Make note of this statement. If you write this expression properly, you will be getting 50% of the marks. If you simplify and then arrive at the answer, another 50% of the marks. These calculations hardly get you any marks. This is a must, because already these things are covered in properties of fluids, right? This is application. That's why the crux lies in writing this particular equation. So now onwards, whenever you solve the problem, make sure that you are able to write the basic equation. Simplification can be done. Now what I have done is PA I have kept on the left hand side, everything I have taken on the right hand side, substituted and simplified to get PA is equal to minus 3580.65 Newton per meter square units. Now this itself can be written as minus 3.58065 kilonewton per meter square, because this can be divided by 1000 to get in the units of kilonewton per meter square. So hope you have understood. Please go through once again and try to understand. Okay, we'll go for the next problem. Here there is one more. For the system shown in figure, determine the pressure at A and B Okay, here there is a point A and there is air here, and there is a point B here. This is a closed container. There is air, of course, but this is open to atmosphere. There is an open liquid. Now what is this liquid? This liquid, you can just see here, free surface is over here. It is oil of relative density 0.8 or specific gravity 0.8. It is running through and through. Over here there is no other liquid. The same oil is coming right up to this, and then here again there is a surface. This surface is not free surface. This is under pressure. This is a free surface. Now for solving, what you have to search is the horizontal levels of the same liquid. Now if you run a line all along this, it is all at the same level because it is the same liquid. Oil is continuous. Okay, now we'll be using specific weight of oil. There is no other liquid here, so we'll solve. Relative density or specific gravity S, we should be knowing that specific weight is equal to gamma is equal to S into gamma W. Gamma W, specific weight of water, is known. Specific weight of oil is calculated. S naught into gamma W, 7848 Newton per meter cube. Now what I'll do is I'll run a line horizontal over here. Okay, we can look at that. That red line I have taken as a reference line, so that pressure at point A is equal to pressure at this point, and this point. Let me name them. So I can now just say pressure at A is equal to pressure at C is equal to pressure at D is equal to pressure at E. So let me write the same thing. PA equal to PC equal to PD equal to PE. Now how can I write the value for PE? Again, I'll start with open free surface and then go down. So PE is equal to, I'll start from here, 0. Again I am considering gauge pressure, because of that atmospheric pressure is considered as 0, and then I go down. That's why there is a plus sign. In oil I am going, so it is gamma of oil multiplied by this distance, and this distance is 8 centimeter. 8 centimeter is 0.08 meters. Or there is one more way of doing the same thing. Now if I start writing at this level PE, I have written that way, PE, and then when I go up, it will be subtracted, so minus gamma of oil multiplied by 0.08, and that should be equal to, when I reach here, the pressure has to be equal to 0. Now you observe this equation or this equation, they have the same thing, slightly written in a different manner. So when you write expression for PE, you can go from here to there, or you can come from there to here. Whichever is convenient, you can practice. But make sure that whenever you move down into the liquid, you have to add. If you go up into the liquid, you have to subtract. Now from this, if I substitute for gamma of oil as 7848 and simplify, pressure at E becomes 627.84 Newton per meter square, which is same as pressures at all these points. So pressure at A will be equal to 627.84 Newton per meter square. Further, now if I want pressure at B, I'll start at point B and then let me move down. So pressure at B, when I move down, if I move horizontally, there is no addition or subtraction, but when I move down, I have to add. There is a plus sign. I am moving through a distance of 0.6. There is a 0.6 in the liquid of oil itself. That's why there is gamma naught or gamma O multiplied by 0.6. So when you come at this level, it is pressure at T. So PB plus gamma O into 0.6 will be equal to PD, but already this PD is known here. I'll substitute that value. So PB plus 7848 into 0.6 is equal to 627.84. If I simplify for PB will be equal to minus 4080.96 Newton per meter square. If you want kilonewton, then it will be equal to minus 4.0898096 kilonewton per meter square. So this is how to analyze the problem. The size of the problem looks huge, but the moment you write a couple of equations and then the time taken would have been hardly 5 minutes, and the extent of mass you expect for these kind of problems is right from 8 to 10 marks. Yeah, I mean, and then you have heard it right, that it is 8 to 10 marks you'll be getting. But if you are not able to write those two important equations, then you would be not getting anything, right? We'll go for one more, the last problem. Read the problem. For the system shown in figure, okay, calculate the air pressure PA, okay, to make the pressure at N 1/3 of the pressure at M. The point N is shown here at the bottom of water. The point M is shown here at the bottom of mercury, which is standing for a height of 10 centimeter. Now you have to find the pressure PA such that the pressure at N is just 1/3 of the pressure at M. That is what is given. Okay, we have two liquids, gamma of water and gamma of mercury. I know gamma of water, gamma of mercury is calculated. You know how to do that now. Now because there is a statement that is pressure at N is equal to 1/3 of the pressure at M, I'll write Pn is equal to 1/3 of Pm. It's given. Now the point is how to write for Pn. I can go from here to there or there to here. I'll start with known PA, right? The PA pressure at any point here, it is same because this column of air does not add up anything. So pressure at A, PA is equal to pressure at this level plus I'm going down into water, gamma W, through a distance of 60 centimeter, so 0.6. So this is nothing but Pn. Now how do I write Pm? Again I'll start with PA. I go down through what distance? This distance is 0.5 meters because this distance is only 0.6 minus 0.1. So this will be 0.5 meters. In water, that's why gamma W into 0.5. I'm going down into water, that's why I have used plus sign over here. Make note of this plus sign. Then again in mercury I'm going down, so there is a plus sign. In mercury gamma M through a distance of 0.1. So I reach the point M, that's equal to Pm. So this is how to write expression for Pn and Pm. Now substitute these two in this equation to get the answer. Now as Pn is equal to 1/3 of Pm, I just simply substitute these values there, this over on this side, and simplify to get the value of PA, which is equal to 294.3 Newton per meter square, which is equal to 0.2943 kilonewton per meter square or kilopascals. Okay, thank you. We'll stop here.